Hello, everyone. How are you doing? I trust you are all doing great. James from JTS Maths Tutoring here. Today, we are going to be looking at question 7 under supplementary exercises in the book Elementary Linear Algebra with the supplementary applications by Howard Anton and Chris Rorres. This is chapter 1, Systems of Linear Equations and Matrices. Find positive integers that satisfy x plus y plus z is equals to 9 and x plus 5y plus 10z is equals to 44. All right, let's get going. I'm going to make use of matrices here and take advantage of our operations. All right, so the very first thing that I'm going to do is to convert the given linear system into an augmented matrix. So what I'm going to do is I'm going to multiply the first row with a -1 and add it to row 2 to get a new row 2. By so doing, I get this. But I can actually take this to row echelon form by further dividing a row 2 by 4, but I decided to leave it right here. So from what I have here, the corresponding system of equations now is going to be x plus y plus z is equals to 9 and 4y plus 9z is equals to 35. So from my second equation, I can solve y in terms of z, or I can solve z in terms of y, and then use the trial and error method right there. The reason being that I'm dealing with small coefficients and very simple equations here. Or I can straight away use the trial and error method on the second equation without solving y in terms of z or vice versa. All right. So I'm looking here at the least possible positive integer, which is 1. If you plug that one in, you can see here that z is not going to be an integer. If I plug in y is equals to 2, I can see that z is actually going to be 3. If I plug in y is equals to 3, I can see that z is going to be 23 over 9. If I plug in y is equals to 4, I can see that z is going to be 19 over 9, of which I can see that here y is equals to 2 is the value to take right here. So when y is equals to 2, my z is going to be equal to 3. What I need to do here now is to substitute in y is equals to 2 and z is equals to 3 into the first equation. By so doing, I'm going to get x is equal to 4. All right? So this means that x is equals to 4, y is equals to 2, and z is equals to 3 is one of the possible solutions. All right? Okay? But now I'm given a constraint here. Number 1, x, y, and z, they must be positive integers. And their sum should be equal to 9. So I'll leave that to you to play around with whatever you can play around with, but I can assure you, you will notice at the end of the day that there is no any other possible solution apart from x is equals to 4, y is equals to 2, and z is equals to 3. So these are the only positive integers that satisfy the given linear system. You can use any method to solve this, but I assure you, this is what you are going to get. So there you are, guys. This is what I have for you today. Allow me to do what my mama taught me. A good visitor knows when to leave, or she would say a good dancer knows when to leave the dance floor. Adios, amigas and amigos. Till we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. See you soon.